Imagine a time when nothing at all existed. No stars, no galaxies, no space, no time, no light, no matter. It's such a deep idea, so completely empty, that our minds have a hard time understanding it. It's absolute quiet, absolute emptiness. An eternity that wasn't eternity because time itself didn't exist. There was only this perfect, featureless void. It's a state that challenges our language and our gut feelings, a canvas without paint, a story without words, a beginning before the beginning itself began. This is the starting point of our cosmic journey, the place before existence itself. In this realm of absolute nothingness, something incredible happened. From this seemingly impossible state of pure void, a glimmer appeared. A single point of endless potential emerged from the void. It wasn't an explosion in space, but the very birth of space and time. It was the birth of reality, the first word in the cosmic story. This initial impulse, this original event, broke the eternal silence and set in motion a chain of events that led to everything we see and know today. The universe was born. This is a moment that challenges our deepest understanding of cause and effect. This sudden appearance of existence raises the most basic question of all. It's a question that has been asked by philosophers, scientists, thinkers. Why is there something rather than nothing? Why does a universe filled with galaxies, stars, planets and life exist at all? This isn't just a scientific puzzle, it's a deep philosophical exploration of what reality is. It makes us face the very foundations of our world and our place in it. The journey to answer this question takes us to the edge of known physics and into the realm of deep mystery. The change from nothing to something is the greatest story ever told. It's a story of cosmic creation, of unimaginable energies, and the slow, patient unfolding of complexity over billions of years. From that first tiny spark, the entire cosmos bloomed. It expanded, cooled, and began to form the structures we see in the night sky. Every star, every planet, every living thing is a direct result of that initial moment. We are all part of this grand cosmic story, a story that began with the simple yet profound question of why anything exists at all. Let's go back to that moment before time even began. Nothingness. Complete. Then a pulse. One bright flash lighting up the darkness that wasn't there before. This is the first light, the start of energy and matter. In this very moment, the basic rules of physics are born. The rules that will guide the universe are set. From this single point, space itself begins to unroll, spreading out in every direction. This event holds the seeds of every galaxy, every sun, every world that will ever exist. This is the universe taking its first breath. As space quickly expands, the young universe is a swirling mess of pure energy. It's a place of unbelievable heat and density. In this chaotic soup, the very first basic particles start to appear, flickering into existence. Quarks, electrons, photons. They come from the pure energy of the Big Bang, showing the deep connection between energy and matter. These particles dance and crash into each other in a wild ballet. The newly formed laws of nature guide them, starting the long process of building a structured universe. This process of creation isn't just an idea. It's the story of how you and I came to be. The atoms, the air we breathe, the planet we call home. They were all made from that first spark. The elements were cooked in the hearts of dying stars. Stars were born from the clouds of gas left over from the Big Bang. We are made of stardust. Our existence is a chain of events stretching back 13.8 billion years. We are the cosmos, aware of itself. We stand today on a small planet around a common star, looking out at the endless night sky. We see the faint light of distant galaxies. Each galaxy is proof of that first pulse. We are children of the Big Bang, able to look back at our own cosmic beginnings and ask how it all started. This journey of discovery is part of what it means to be human. The search for knowledge and meaning, driven by the same curiosity that first made our ancestors look at the stars and wonder about their place in the universe. The Big Bang wasn't an explosion in space. It was the superfast stretching of space itself. Space began. Time began. They both started from a super-dense and super-hot state. In a tiny fraction of a second, the universe blew up like a balloon. Tiny wiggles got stretched out, like ripples on a balloon. These wiggles were the first seeds of everything. Later, they would become galaxies. Later, they would become groups of galaxies. At first, the cosmos was a smooth, swirling hot soup of plasma. Photons were dancing closely together. Electrons were dancing closely together. Nuclei were dancing closely together. Light couldn't travel freely. The universe was like a thick fog. As it grew, it kept getting cooler and cooler. This cooling allowed new things to happen. The patterns that were set during the ballooning stage would grow because of gravity. Small differences became big differences over time. Gravity was patient and never gave up. It pulled matter together in places where there was a little bit more of it. These spots got heavier. The stuff around them fell in. Threads started to appear. Empty spaces started to appear. On the biggest scales, the cosmos ended up looking like a giant web. How fast it expanded at the start set the whole stage. It decided how fast things would spread out. This speed affected how matter could clump together. It also set the size of the part of the universe we can see. From these early settings came the cosmic microwave background radiation. This faint glow holds the fingerprint of those first seeds. It's our oldest picture of the baby universe. We often think of a vacuum as completely empty, like it's the absence of all matter, a perfect nothing. In our everyday world, this idea works just fine. If you take every single atom out of a box, you'd be left with nothing. But the universe, at its most basic level, doesn't play by these simple rules. It follows the strange and wonderful rules of quantum mechanics. And in the quantum world, the idea of nothing gets a lot more complicated and interesting. The vacuum isn't a calm, empty void. It's a bubbling, dynamic and lively place, full of potential. Quantum field theory reveals an amazing truth. Space itself isn't empty. It's filled with invisible fields. There's the electromagnetic field. There's the gravitational field. There are fields for every basic particle we know about. These fields stretch through every part of space, even in what we call a perfect vacuum. They are the basic fabric of reality. What we see as particles, like electrons, photons, are just tiny wiggles or bumps in these basic fields. So even when there are no particles, the fields themselves are still there. They are the quiet, unseen stage where the cosmic play happens. The lowest energy state of these fields is what scientists call the quantum vacuum. But lowest energy doesn't mean zero energy. Because of Heisenberg's uncertainty principle, there's a natural fuzziness to reality at the quantum level. The value of a field can't be perfectly zero everywhere, all the time. There will always be tiny, unavoidable jitters. These are quantum fluctuations. So the vacuum has a minimum amount of energy, a zero-point energy that can never be removed. The void is alive with this bubbling energy, a hidden well of potential that fills all of space. This changes how we understand nothingness. The vacuum of space isn't a quiet background. It's an active player in the universe. It's a place where energy and potential are always in motion, an area where the difference between existing and not existing gets blurry. This quantum void is very different from the absolute nothing of philosophy. It's a real physical thing with properties we can measure and effects we can see. Understanding this active vacuum is the first step to figuring out how the universe could have come from a state we once might have called nothing. The deeper we look into the rules of nature, the more we run into a surprising mystery. The universe seems perfectly set up for complex things and life to exist. The basic numbers of physics, like the strength of gravity, the charge of an electron, the mass of a proton, and how fast the universe is growing, all have values that fit into an amazingly small range. If any of these values were even a tiny bit different, the universe as we know it couldn't exist. It's like we're living on a cosmic knife edge, in a delicate balance. This is what we call the fine-tuning problem. Take the strength of gravity, for example. If it were just a little bit stronger, stars would burn their fuel much faster and hotter, and probably blow up sooner. If gravity were a bit weaker, stars and galaxies might never have formed at all. The early gas clouds would just spread out, leaving a cold, dark and empty universe. The same delicate balance applies to nuclear forces. A small change in the strong nuclear force would stop carbon from forming in stars. Without carbon, the universe would be a simple, lifeless place. The speed at which the early universe expanded is another example of this precision. If the initial expansion was slower, it would have led to a big crunch. If it was faster, matter would have flown apart too quickly for galaxies to form. The amount of dark energy we see is so small, it's like balancing a pencil on its sharp tip for 13.8 billion years. This level of fine-tuning is truly mind-blowing. It's not just a few random coincidences. Scientists have found dozens of these numbers that seem perfectly set to allow a universe that can create observers. This brings up a huge question. Is this fine-tuning just good luck, a basic fact about our universe with no deeper reason? Is there some undiscovered law of physics that makes these values what they are, meaning they couldn't be different? Or is there another, more extreme explanation? The apparent design of our universe makes us wonder if our cosmos isn't the only one, and that we are part of a much bigger, more varied reality. We've journeyed from the edge of nothingness to the huge cosmic web we call home. We've explored the fiery birth of the Big Bang, the strange and energetic nature of the quantum vacuum, and the breathtaking idea of a multiverse of worlds. We've seen how a universe full of matter and energy could come from a state of zero total energy, a cosmic free lunch, if you will. We've bumped into the limits of our language and how we usually think when it comes to the real nature of reality. Science has given us a powerful and elegant story, a tale of how the cosmos changed over time, from a tiny quantum wiggle to the rise of thinking beings. And yet, after all this exploring, we come back to the question where it all started. It's a question that the philosopher Gottfried Wilhelm Leibniz clearly asked centuries ago. Why is there something rather than nothing? Science has given a possible answer to how something can come from the physical version of nothing, the quantum vacuum. It has shown a path from a state of being possible to a state of being real. But this doesn't touch the deeper philosophical question. Why does the quantum vacuum exist at all, with its elegant rules of physics? Why not a complete philosophical emptiness of pure nothingness? Here lies the current limit of science. Physics describes how the universe works with amazing power and accuracy. It explains the rules of the game. But it doesn't explain, and maybe can't explain, why the game is being played at all. Why are there rules of physics? Why is there a reality that follows these specific rules, or any rules at all? This question pushes us beyond things we can test into the realm of big ideas, philosophy and faith. It reminds us that for all we know, the universe still keeps its biggest secrets in deep and humble silence. And here we are. We are a collection of atoms, forged in the hearts of stars that died long ago. We are matter that has been recycled and put back together over 13,800,000,000 years of cosmic history. We are the amazing result of a chain of events that began with a random flicker in the first emptiness. We are, in the most literal and poetic sense, stardust. The iron in our blood, the calcium in our bones, the carbon in our DNA. Every part of us is a leftover from a star explosion, a gift from the cosmos. We are living, breathing proof of the universe's creative power, a part of the cosmos that woke up. On this small, delicate planet, spinning around an ordinary star in a quiet corner of the Milky Way, we have developed an amazing ability. We can look at the night sky, at the very stars we came from, and we can think deeply about it. We can build telescopes to look back in time to the very beginning of creation. We can come up with theories that describe the birth of space and time itself. We, a tiny speck of cosmic dust, have become the way the universe understands itself. The curiosity that makes us ask why is the universe asking about its own existence. It's a deep and beautiful cycle that we are a part of. This journey, from nothing to stardust, from the Big Bang to human minds, is the greatest story we know. It's a story of huge violence and peaceful beauty, of mind-boggling sizes and tiny, tiny particles. It's our story. It connects each of us not just to each other, but to every galaxy, every star, and every atom that exists. It fills us not with a feeling of being small, but with a feeling of deep connection and belonging. We are not just observers of the universe, we are a key part of its ongoing story, a testament to what it can become. Let's keep looking up at the sky with wonder and curiosity. The cosmos is huge, and we've only just begun to explore its edges. There are more puzzles to solve, more amazing things to find. The search for understanding is a never-ending journey, and it's one of the most noble things the human spirit can do. Because by asking questions about the universe, we are fulfilling our cosmic purpose. We are the stardust that fell to Earth, learned to walk, and started dreaming of going back to the stars. And now, I'm really curious to hear what you think. What do you think? Why does the universe even exist? Is it an accident? Is it just how physics works? Or is it part of something much deeper? Share your thoughts in the comments below. I always read your comments, and I'll do my best to answer the most interesting questions. Maybe your ideas will hold some of the most surprising answers. If you like this video and want more cosmic stories like this, please support the channel. Give it a thumbs up, share this video with your friends, and subscribe to Cosmic Curiosities so you don't miss new journeys into the deepest mysteries of the universe. And remember, every time you look at the night sky, you're looking at one of reality's greatest mysteries. See you in the next video.